Hi guys, and welcome back to our Inside AMG F1 special from Brixworth. Now if you've seen part 1 already, you know that we dive deep into the technical specialties at AMG high performance powertrains. Part 2 gets even more exciting, so there's a lot to look forward to. Let's jump right into the video. It's so clean here, it's like a lab.
We got an F1 engine in there, and we'd like you to fit a water pump on there.
Nice.
I introduce you to Jaden, who's going to guide you during the pump assembly.
There he is.
Yeah.
Jaden, nice to meet you.
Nice to meet you too.
Awesome, so you're going to show me around and make sure I don't make a fool of myself?
Yeah.
Awesome.
So what we're going to be fitting is a water pump to the power unit. We will get you some gloves here.
All right, thank you.
We get
Got it.
you to do that.
Thank you. All right, so I just... Okay, so I suppose these are the connectors, they go in here, right?
Yeah, you want to line those up and try not to snag an O-ring.
Okay.
So if you, as you put it in facing towards the power unit, and once it's in, bend it towards yourself, you should just go in with a wiggle and a push. If you apply constant pressure, just like that.
A little further, or am I
No,
in?
that looks like it's seated in properly.
Everything looks lined up.
Yeah.
Awesome.
So we do now have the fixings, and there's only 3 mounting points. So the 3 mounting points are there, there, and there's one back here. So again, it's also quite important not to cross-thread a bolt.
It's so crazy how little space you got. I mean, everything is so cramped in here, and all these different components and all the the little angles and stuff, and crazy.
Yeah, access can be limited at times.
There we go.
Awesome,
Now
and
the
there's
rest of the torque wrench.
just the last one back here. You just got to get it at the right angle just to get it to almost bite into the thread.
There we go.
Yeah, you want to try to get the tool as straight as possible.
Ah, okay.
So yeah, it should be going in
there
now.
we go. Ah, yeah. Now it works.
Yeah.
How long does it take you to mount one of these? Probably just 2 minutes.
Yeah, it doesn't take too long. We'll be talking up to 7 Newton meters.
Okay.
That will just snap onto there like that, and it will beep at you once you've reached your desired torque.
All right. I'll hand that over to you.
So if you want to go in the same order as the way you fitted it.
Got it. Perfect.
Now we will be fitting an elbow from the water pump to the scavenge pump.
Okay.
So if I
Thank
hand you
you.
those. So the first thing you want to do is see if you can get this on as square as possible.
Mm-hmm.
Because again, you don't want to pinch an O-ring.
All right. Try to be very gentle with it.
Yeah.
That looks about right.
Yeah, you've fitted that perfectly.
Nice.
So again, 1, 2, and 3,
Got
and
it.
we will Cleco up again after.
That is so awesome. I can't believe I'm actually working on an F1 engine.
Yeah, it can be quite surreal at times. And again, it's a bit surreal when you actually see the product in use.
That must be one hell of a feeling, like watching TV and actually going like, yes, I was a
Yeah.
part of that.
Yeah, it really is. It is quite special to work here.
That's number 1, number 2, and number 3. We're all set.
You've just successfully fitted a water pump to the power unit.
Awesome. That is so cool. Thank you very much.
No worries.
Cool.
Well done, Felix. You're natural, aren't you?
Well, I wouldn't say
noticed.
that, but I gotta say it was a lot of fun.
Yeah.
Cool.
Hopefully Lewis and George will be happy with that.
I hope so, yeah.
Should we go and see where those engines get tested next?
All right.
Let's go to
do that.
Dino.
Thank you very much,
Thank
Jay.
you.
See you.
Thank you. Nice to meet you.
And this is the Formula One dyno area, where we do all our experiment to make sure that the parts we talked about are being tested thoroughly before they hit the track. And then we've also got here, similar to what they have in Brackley, the trackside support office, where we can support the race from here. So it means we don't have to send so many people to the track. So all the data comes back live, and then we can react and look, make sure the engine is healthy and so on. So, but I understand Adam's waiting for us now, so I'll take you back to AMG1.
Nice.
And you can pick you up from there.
Cool. Thank you.
So I hope you enjoy looking around. We're back with Adam, so I'll hand you back over. He's going to show you about Project One.
All right, awesome.
Thanks, Pierre. So Felix, you know hopefully most of our secrets, but not all, Pierre?
Not all of them. I have some back.
Okay, great. How about we now talk about how Formula One moves into AMG One?
Absolutely.
Cool.
Let's do that.
Let's do that. Thank you, Pierre.
Enjoy.
Thank you.
Okay, let's go upstairs. So Felix, here we are in the Hybrid Technical Centre. I think it'll look really familiar to what you've just seen over the road.
Lots of people working here.
Lots of people working, lots of engineers, same environment, really, really open plan. We try to encourage lots of communication, lots of innovation, and have that ad hoc bumping into someone, have a conversation over a coffee. It's where some great ideas get founded.
Cool.
So we've got another power unit. That's a 2015 power unit, but you know all about that now. So let's talk a little about AMG One.
Nice.
And how the power unit translated into that.
Awesome.
So the rear axle really is a Formula One power unit.
Okay.
Same as we've described and discussed earlier. When we get to the battery, we needed more energy. Okay, so we've actually got 4 times the amount of cells.
4 times?
4 times.
Wow.
Still the F1 cell, yeah, same cell, but 4 times as many to give us a larger amount of energy and therefore serving the needs of AMG One. We've got twice the amount of electric motors because on the front axle, yeah, we've got an electric motor on each corner, independent. And those motors are the MGUKs. So that means another 120 kilowatts on each side. So that's 240 kilowatts of power on the front axle where you can control them totally independently.
So actually the same concept as in F1, just more power, basically. I mean, that sounds like just the right mixture.
Exactly. And then when we start to think about chassis dynamics, the ability to go into torque vectoring, it gives us a massively flexible powertrain. So it's really complex, but super, super potent. Should we go and see a little bit more about it?
Absolutely. You lead the way.
So Felix, you've got an idea of the layout of AMG One. As you know, we've had lots of technical challenges. One of them was NVH, noise, vibration, harshness, which surprised us. It's not something that's normal for us in Formula One. But let's have a bit of a chat about the challenge we had there with our electric machines, with the MGUK that we've already spoken about,
Yes.
what we had to change and why. So I'd like to introduce you to Stuart.
Hello there.
Hi.
Nice to meet you.
Nice to meet you, Felix. Welcome.
Stuart's a team leader that's been involved at the heart of Project One, AMG One as it is now, throughout. So, Stuart, can you explain a little bit about what we needed to change from a Formula One MGUK to get NVH that's acceptable, more than acceptable for a customer, whilst retaining all of the performance?
Yeah, so for the AMG One hypercar, so we're taking the Formula One technology and applying that to the road car. So we took the MGUK, which is the motor, 120 kilowatts attached to the crankshaft, and we needed to use that in that same location for AMG One, but also use that motor for driving the front wheels because it's a four-wheel drive architecture. We took that technology, designed our own gearbox to attach the motor to, and then we worked with our colleagues at AMG, the specialists on NVH, did the testing with them. They used their specialist equipment, and we measured the NVH. For us in Formula One, ordinarily at HPP and in Formula One, NVH is not an issue.
I figured, yeah.
Not
a priority.
Yeah, so this was new for us, which is where we used our colleagues within AMG. We measured the NVH values because it's a legislative requirement.
Yeah.
For the drive-by tests, the values were 74 decibels. That's the target we needed to achieve.
How do you figure out how to get NVH better?
So within HPP, we have electromagnetic simulation experts and electromagnetic motor experts. So we called upon their expertise, but that's all in theory and simulation. So part of my team's task was to turn that into reality. So that's when we go to looking at what hardware we would need to change, and also looking at different winding technologies, different materials, stiffening housings and covers, different speed sensors for road car safety application, for example, was another aspect we needed to look at. NVH covers and different materials. Also looking at the thermal properties of the architecture we were proposing. Cooling was especially difficult with the new winding layout we proposed with the 24 slot machine, which is what we changed to.
Okay, 24 slots, that means exactly what?
Electromagnet you set up with the coils within there. The number of slots in the stator is 24.
Okay.
and that's a higher number than we have in Formula One.
So the more coils you got, the better the NVH. Is that something you could say about the MGUK?
Yes.
Okay.
In our case, yes.
Yeah. Nice. Can we maybe take a closer look at that?
So we have here, what you see on the left here is the 3D CAD of the final MGUK technology. So the internals of this are the same as we have in the what we call the MGUF, which is on the front axle.
Okay, so that's mounted to the crankshaft, and that's at the front axle.
That's onto the front axle gearbox, yes.
Got it.
Yeah, for the front wheels, one on each side. So there's two of these, and one MGUK per powertrain.
Nice.
And here we have the physical hardware.
It's actually quite compact when you see it in person.
Yeah.
And it looks, well, almost just like the one we saw downstairs at the powertrain we looked at, where it was
Yes.
mounted to the engine.
Yeah. So one of
pretty
the
cool.
main considerations for us also was to meet the NVH requirements, because that was a legislative requirement, but also this is a hypercar Formula One technology, so we couldn't compromise on the performance. So the 120 kilowatts performance level that we have in F1 had to be achieved on our new architecture, but also meeting NVH.
Can we maybe take a look inside? How these different coils, how they come together?
So I can take you downstairs and we can look at build and walk you through the build process there, and also look at some of the automation challenges we had.
That would be
because
super cool.
we have 3 of these motors per vehicle, so for us that's 1,000 motors, or just shy of 1,000 motors. So in terms of process and efficiency of process, that's a big challenge for us also.
That's a lot of coil winding.
Yes.
All right, let's take a look.
Okay.
You lead the way.
Cheers.
This is really next level. I feel like we're about to walk into an OR.
So this is the motor build area. So we obviously have very high standards of cleanliness in this area. So what we have here are various stages of the stator build. So these are the internals of the motor that you saw upstairs, the physical finished motor and the CAD on the screen. So these are the slots in the stator which we spoke about.
The 24.
The 24 slots. So internally to there, they're made up of lamination levels, which reduces the eddy current losses, which maximises the efficiency. And we've been able to match the efficiency of the Formula One motors.
Wow. That is crazy cool. And how do you put all that together? I mean, that's just miles and miles of copper wiring.
So this is a different architecture to the Formula One motors, which was new to us at HPP. Within Formula One and for our development motors, we hand wind them. But for Project One, we have up to 1,000 motors to make. So the time constraint, or the time impact on winding these by hand, and also the quality and repeatability of doing that manual process, wasn't suitable for the AMG hypercar. So based on the back of that, we have an internal HPP automation team, and they've developed in-house new technology and tooling bespoke to HPP and to this project, which we can now look at inside the build room.
Awesome. I can't believe we actually look at the components of the road-going version of the AMG One, the car that's been awaited for so long, and this is where it's put together.
Yes, this is the coil insertion machine that you see here, which was developed within HPP.
That looks insanely complicated. Almost looks like a Christmas tree.
Yes.
And that would then move up and down and rotate, or how would that work exactly?
Yes, so I think we can get an example of it in use, which we have here now.
Oh, perfect.
One of the challenges here is to ensure that we don't snag any wires on the way in. So we have another machine inspecting the quality of the full length of wire prior to this stage.
Oh, yeah. So now it's doing all the inspecting and seeing if everything is in the state that it should be.
Yeah, there's some visual inspection processes as part of this machine.
And that's what we see on that screen right there, right?
Yes.
Can't believe I actually get to watch this. This is going to go in one of the AMG ones that's going to be on the road very soon.
So the insertion loads are measured as well as part of this process. So it's driving the coils up into the stator housing so that we reach that finished coil wound assembly. So on the automotive side, we have the added constraints of some legislative requirements, which specifically for this includes NVH.
And of course, with this machinery, you managed to achieve a high level of, well, repeated quality of the highest standard.
Yes, and improves the efficiency as we strive for efficiency throughout every area of HPP, and this improves the yield and the quality of the finished product.
And then this machinery that drives well, the copper wiring to all of the 24 slots
Yes.
until the whole stator is, well, just packed with wiring.
Yes, that's it. The fill efficiency, so the amount of copper that we can repeatably achieve inside of the electrical machine, that helps with the efficiency as well. So after the coil winding process, there are various stages of the electric motor manufacturing sequence which go through to result in the finished component you see upstairs. Mm-hmm. And then that component has been through various validation tests to ensure that what we set out to achieve was actually achieved in development. And now we have that in production, and if you'd like we can go and see one of these electric motors running with the rest of the powertrain around some laps of Nürburgring.
Oh, absolutely, yes.
Okay, let's go to the dyno.
Awesome.
So Felix, as part of the durability and validation prove out, we have to physically test what we've designed and the whole team have built. And some of these rig rooms you see here on the left are where we can do component testing. Mm-hmm. Once we are sure that that component is durable and achieves the performance and other parameters which the component must meet, we then progress into the dyno where we run the full powertrain.
Nice.
This is where we replicate everything you see under that cover of that car in real life.
Awesome.
You might be able to hear something, Felix.
Yeah, I can hear a slight buzz in the background.
Slight buzz. So, Dyno 7 behind us. This is where we've done hundreds of thousands of kilometres of durability testing of AMG1's powertrain.
Nice.
Okay. Do you want to see it?
Oh, of course I do.
Let's take a look. So Felix, welcome to Dyno 7.
Oh, there it is, and it is alive.
There it is, naked.
Wow.
Okay, so what we've got here, imagine you're stood behind AMG1. Okay,
Wow.
we've got the rear axle, you can see the wheels effectively spinning, so they're there to replicate all the wheel loads. We've got the engine running, we've got the battery in front of the engine exactly in the position it's in the car. Then in front of that, we've got the front axle that you can't really see that well from here, but basically we've got the whole car without the chassis.
That is so crazy. It looks like it's on a life support machine.
That's exactly what it is.
Yeah.
So our dyno guys, they create the environment. They make sure that all of the life support systems are at the right temperatures, the right pressures, the right flow rates. So the powertrain thinks it's actually doing a lap of the Nordschleife. And that's what it's doing right now.
It's actually on the Nordschleife. Wow.
On the Nordschleife. As part of our normal prove out that we've done with AMG1, we've done thousands of different laps. We have country laps, as if to simulate going cross-country, city cycles, EV driving, but of course, where is AMG1 at home?
On the Nordschleife, on the racetrack.
On the racetrack.
Yes.
Yeah? You've got all the power, you've got all the aero, the downforce. That's where AMG1 comes alive. That's where I think our customers will really see how special it is, because they've got a Formula One power unit in the back of their car, and then a modified part of that at the front to give them over 1,000 horsepower.
That is so cool, and it's so amazing to see how it all comes together. Like over the years, all the development process, so many different parts, so many different people coming together to create this, and now it's on the road, and I can see it here on the dyno. That's just, it's surreal.
Exactly, and I think you've got a feeling for the complexity. Our customers have shared a difficult journey. We never knew it would be this difficult, but we've come across those challenges. And we've worked as a team. The relationship here, HPP and AMG, you might feel it's quite similar.
Actually, yeah.
Yeah?
Yeah.
Even in terms of its location, it's out in the countryside. Yeah, Brixworth or Falterbach, it's a little bit similar.
Yeah, true.
And the environment equally. Yeah? We want people to be working to give us the best product, whether it's Formula One, AMG1, any of our advanced technology projects.
And that's really what you can feel when talking to the people here as well as in Falterbach. The level of passion for the product, for their jobs is so high over there and right here as well. That is really what makes it even more special, getting to know the people behind this amazing project. It all comes together beautifully, and you see those parallels really a lot between Brixworth and Falterbach as well. Yeah.
Exactly, and it's the people that make the difference.
Yeah.
The great facilities, the amazing infrastructure, you need it, but making the best use of it, that's about the team. That's about the people, that's about the hunger.
Yeah.
That obsessive madness of chasing performance, of chasing efficiency, of chasing every win that you can. So we've seen AMG 1 on the test bench. How about we go and have a drive?
You're kidding.
On the road.
Really?
Let's do it.
Absolutely. Nice.
So here she is, AMG 1.
Awesome.
Should we take it for a ride?
Absolutely.
Let's
nice.
do that.
So there you have it. A jam-packed double feature comes to an end. Can't believe the level of engineering excellence and passion that goes into the Formula One cars, and this car, the Mercedes-AMG 1 as well, that's on the road now. Absolutely unbelievable. Thank you to the guys at the Mercedes-AMG Petronas Formula One team in Brackley, and also here at Mercedes-AMG High Performance Powertrains in Brixworth. It's been truly amazing. If you like what you've seen, don't forget to like this video. Also drop us a comment down below, letting us know what you would like us to shoot next. Subscribe to the channel, also hit the bell icon so you always get notified whenever we upload a new video. And for Adam and I, it's now time to go for a spin.
Let's have some fun.
Oh yeah.